Hello you guys. Today we're going to do something really cool. We're going to solve equations with variables on both sides of the wall, okay? So take a look at example 1. I copied the equation exactly like they wrote it. 5n minus 7 equals 9n plus 21. Now, with my red pen, I added a line and changed the sign in front of the 7. But I want you to notice how I used the orange pencil, okay? I put an orange wall down. And the reason I did that is I want you to notice how there's 5n on the left-hand side of the equal sign and 9n on the right-hand side. So anytime that the variable is on both sides of the equal sign, I'm going to change my strategy a little bit. Watch what I do. Grab your red pen, and I want you to notice how I put a box around the 5n on the left-hand side and a box around the 9n on the right-hand side, and then I bring down the wall. Here's the deal. You have to pick one of them to destroy. It really doesn't matter which one, but most algebra teachers will tell you pick the one with the smallest coefficient. That means the smallest number in front. So see how there's a positive 5n and a positive 9n. Well, the positive 5n is the smaller one, so that's the one I'm going to destroy. Now, when I say destroy, I have to destroy the whole entire thing. So see how 5n is being added to the negative 7? I'm going to subtract 5n from both sides of the wall, okay? And so now I simplify. 5n minus 5n destroys each other, so they cross out, they disappear. I let the negative 7 slide down, let the equal sign slide down. Now 9n minus 5n gives me 4n, and then I let the plus sign come down, I let the 21 come down. So now I have a two-step equation that I know how to solve. I'm going to circle my variable and bring down the wall, and then see how adding 21 is touching the circle, so I get rid of it. I subtract 21 on both sides of the wall, and then I simplify. Negative 7 minus 21 is negative 28. I bring down the equal sign, I bring down 4n, and then of course positive 21 plus negative 21 destroy each other. So now I just have 4n equals negative 28. And so I circle my variable, I bring down the wall, I have to get rid of that 4, so I'm going to divide both sides by positive 4. So I have negative 28 divided by 4 gives me negative 7. I let the equal sign come down, and of course 4 divided by 4 destroy each other, so I get that 1, and then I let the n come down. Now example 2 is really cool because what happens that sometimes when you have variables on both sides of the equal sign is you can have a situation that's no solution. And this is called a special case in algebra, okay? So let me show you what that looks like. They gave me an equation, 3 times the quantity 2x plus 1 equals 6x. So I wrote it down exactly like they gave it to me. And now use your red, circle the 3, and we're going to distribute it. So draw the two rainbows. And so 3 times 2x gives me 6x. I bring down the plus, and 3 times 1 gives me 3. I let the equal sign come down. I let the 6x come down. And now, remember, when variables are on both sides of the wall, I use orange, okay? So I'm going to underline the 6x on the left and the 6x on the right, and I have to pick one of them to destroy. So I grab my red and I put a box around the 6x, and then I bring my wall down and a box around the other 6x. Now remember, you're supposed to pick one of them to destroy, and it doesn't matter which one in this case. They're both the same coefficient. So let's say I want to destroy this one. So if I'm going to get rid of the 6x that's being added, I'm going to subtract 6x on both sides of my wall. Okay, so now a positive 6x plus a negative 6x, you know how we usually say, oh, they destroy each other and disappear? This time I want you to make sure you show me they become 0, because that's really what's happening. It becomes 0x, which is just 0. And you bring down the plus, bring down the 3, bring down the equal sign, and again, 6x minus 6x produces that 0. Okay, and then you simplify. Well, you say 0 plus 3 equals 3, and then you bring down your equal sign, and you bring down the 0, and then you say, well, wait a minute. 3 does not equal 0. Never, ever, ever. That can't happen. And so when that situation comes up, when it's something that you know is absolutely not true, never will be true, that means no solution in algebra. Okay, now here's in example 3 is another really cool special case in algebra when you solve an equation and every number in the universe is a solution. So there's an infinite number of solutions. Let me show you what that looks like. So let's say they gave us 4 times the quantity x plus 2 equals 4x. So we wrote it down exactly like they gave it to us. Grab your red, circle the 4, draw 2 rainbows, and then do the distributive property. 4 times x gives you 4x. Bring down the plus sign. 4 times 2 gives you 8. Let the equal sign come down. Let the 4x, let the plus, let the 8 come down. Okay, and then I grab my orange because I saw that I had variables on both sides of the wall. So I say, okay, I have to pick one of them to destroy. So I put a red box around the 4x on the left and a red box around the 4x on the right. And I say, well, I'm going to pick one of them to destroy. Let's say I destroy this one. All right, so if I see a positive 4x that's being added, I'm going to subtract 4x on both sides of my wall. And so a positive 4x minus 4x produces that 0, so you have to write it this time. Let the plus sign come down, let the 8 come down, let the equal sign come down, and then positive 4x minus 4x, again, produces that 0. Write it down, and then let the addition sign come down, let the 8 come down. And then you just simplify. Well, 0 plus 8 gives me 8. I let the equal sign come down, and 0 plus 8 gives me 8 again. And so you say, wait a minute, 8 equals 8? Well, yeah, of course, always. That's always, 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 always true. And so we would say, for this case, that the solution is all real numbers. And what that means is any number that you substitute in for x, any number in the universe, will make this a true statement. So we say the answer to this is all real numbers. Okay, so now we're going to solve these equations. You need to show the work and look out for special cases, okay? So now look at number 1. 3n minus 6 equals 5n plus 20. So I copied it down exactly like they gave me the problem, and I grabbed my red, I added a line and changed the sign in front of the 6. Now I'm going to use my orange pencil because I noticed that I had variables on both sides of the wall. And so with my red, I'm going to put a box around the 3n, the whole thing. And then I brought down the plus, brought down the negative 6, brought down the equal sign. I put a box around the 5n, brought down the plus, brought down the 20. And remember, I have to pick one of these to destroy. Now, normally in algebra, we pick the one with the smaller coefficient, the 3n. So I say, okay, I want to get rid of positive 3n that's being added. So I'm just going to subtract 3n from both sides of the wall. And so now I simplify. A positive 3n minus 3n goes away. It becomes 0. It disappears. I bring down the negative 6. I bring down the equal sign. 5n minus 3n makes 2n. I bring down the plus, bring down the 20. Now I have negative 6 equals 2n plus 20. And so I circle my variable. I bring down the wall. And I have to destroy the adding 20. So I subtract 20 on both sides of my wall, and I simplify. Negative 6 minus 20 is negative 26. I bring down the equal sign, bring down the 2n, and positive 20 plus negative 20 destroy each other, so they disappear. Now I have 2n equals negative 26. So I circle my variable, I bring down the wall, and the only way to get rid of that 2 is to divide both sides by 2. And so then I simplify. Negative 26 divided by 2 gives me negative 13. I bring down the equal sign. 2 divided by 2 just creates that giant invisible 1. And then I bring down the n. Take a look at number 2. 12x equals 4 times the quantity 3x minus 1. So I copy it down, and then I grab my red, and I added a line and changed the sign in front of the subtraction. And I circled my 4 and I drew the rainbows because I saw this was distributive property. So now I bring down the 12x, bring down the equal sign, and I do the distributive property. 4 times 3x gives me 12x, and I copy the addition sign. 4 times negative 1 gives me negative 4. So now I have 12x equals 12x plus negative 4. Well, I see that I have x's on both sides of the wall, so I used orange just to point that out to you. And now, grab your red, put a box around the 12x on the left, and draw your wall. Put a box around the 12x on the right, and that's plus -4. And so you have to pick one of the x's to destroy. Well, since they both have the same number in front, the same coefficient, I'm just going to say, all right, let's destroy this one. So 12x, to destroy it, I would have to subtract 12x on both sides of my wall. And so 12x minus 12x produces that 0. Bring down the equal sign. 12x minus 12x produces a 0. And then I bring down the plus, bring down the -4. So now I simplify. 0 plus -4 gives me -4. So I bring down the 0, bring down the equal sign, and I say, wait a minute, 0 does not equal -4. Can never, ever, ever happen. So that's a no solution. There is no solution to that equation. Okay, take a look at number 3. We have 3 times the quantity 2n plus 4 equals 2 times the quantity 3n plus 6. So I copied it down. I grab my red and I circle the 3 and draw 2 rainbows. I circle the 2 and draw 2 rainbows. Okay, now I do distributive property on both sides. So 3 times 2n gave me 6n. I copied the plus. 3 times 4 gave me 12. I let the equal sign come down, and then I do distributive property again. 2 times 3n gives me 6n. Copied the plus, and then 2 times 6 gives me 12. All right, now I have 6n plus 12 equals 6n plus 12. Well, I grab my orange pencil and I underline the 6 n's on both sides of the wall. And then I grab my red and I'm going to box the 6n on both sides of the wall because I have to pick one of them to destroy. And since they have the same number in front, the same coefficient, it doesn't matter which one you destroy. I just said, okay, let's destroy this one. So if I see 6n being added to 12, I'm going to subtract 6n from both sides of the wall. And then I simplify. 6n minus 6n produces that 0. And then bring down the plus, bring down the 12, bring down the equal sign. 6n minus 6n, again, produces a 0. Bring down the plus, bring down the 12. And then you just simplify both sides of the equal sign. So 0 plus 12 makes 12. Bring down the equal sign. 0 plus 12 makes 12. And then you look at it and say, well, 12 equals 12. And you go, yeah, of course, 12 always equals 12. Always, always true. So this is a special case where we say the answer to this is all real numbers. There's an infinite number of solutions to this problem. Okay, and then take a look at number 4. I have 2x plus 7 equals negative 2x minus 13. So the first thing we do is write it out exactly like they gave it to us. And then I grabbed my red and I added a line and changed the sign in front of the 13. Now, I used my orange pencil because I put a wall down and I saw x's on the left and x's on the right. So now I'm going to use my red and box the whole entire thing. Box the positive 2x on the left, bring the wall down, and box the negative 2x on the right. Now remember, you're supposed to pick the one with the smaller coefficient. Well, negative 2 is a whole lot smaller than positive 2, so let's destroy the negative 2x. So the only way to destroy negative 2x is if I add a positive 2x on both sides of my wall. So 2x plus 2x makes 4x. I let the plus sign come down, let the 7 come down, bring the equal sign down, and then negative 2x plus a positive 2x destroy each other, so they become a 0 and disappear, and then let the negative 13 come down. So now you have 4x plus 7 equals negative 13. And so circle your variable, bring down your wall, and then you have to get rid of the adding 7. So you want to subtract 7 on both sides of the wall. And so let the 4x come down. Positive 7 plus negative 7 destroy each other. They become invisible. They're 0. They're gone. Let the equal sign come down. And then negative 13 plus negative 7 makes negative 20. So you have 4x equals negative 20. So now you circle the variable, bring down the wall. The only way to get rid of that 4 in front of the x is to divide both sides by 4. So 4 divided by 4 produces that invisible 1 in front of the x. Let the x come down, let the equal sign come down, and negative 20 divided by 4 makes negative 5, and you're done. Okay, these are really fun. It's using geometry and algebra. So they want us to find the perimeter, keyword, underline it, of the square, keyword, underline it, okay? The first thing you should know is that if it's a square, all the sides are equal. So I showed you the height in red is x plus 6, and the base in blue is 3x. Well, if it's a square, then they have to equal each other, and that's how we set up the equation. So we set up 3x has to be equal to x plus 6. And so I grabbed my orange pencil, I brought that wall down, and I just underlined the x's on both sides of the wall. And so now with our red, let's box the 3x, bring down your wall, and box the 1x. Now remember, x's on both sides of the wall, that means you have to pick one to destroy. And since a 1 is a whole lot smaller than a 3, I'm going to destroy this 1x. And the only way I can destroy a positive 1x is to subtract 1x on both sides of the wall. And so that's what I did. 3x minus 1x made 2x, and then I brought the equal sign down. 1x minus 1x destroy each other. They become 0 and disappear, and then bring down your 6. And now you have 2x equals 6, so I circle the variable, bring down the wall. The only way to get rid of the 2 is to divide both sides by 2, so I bring down the x, bring down the equal sign, and 6 divided by 2 gives me 3. Now I'm not exactly finished because yes, I found out what x is 3, but I didn't answer their question. They want the perimeter of the square. So I substituted a 3 in where I saw x in the problem, and then so that told me that the base is 3 times 3, which is 9, and the height is 3 plus 6, which is 9. And so if I want to get the perimeter of the square, I would just say 9 plus 9 plus 9 plus 9, or 9 times 4, and that would give me 36 units. So the perimeter is 36 units. Okay, so now they want you to find the perimeter of the square. Again, perimeter is a keyword, square is a keyword. And so look at number 5. The base is 5x, and the height is the quantity 3x plus 8. So if it's a square, remember the 5x has to be exactly the same as the 3x plus 8. So that helps me write the equation here. And then I used my orange and I underlined the 5x and the 3x, and I brought that wall down. Now with the red, remember, box the whole thing. Box the 5x, bring your wall down, and box the 3x. And you have to pick which one you're going to destroy. Since the 3 is smaller, I'm going to destroy 3x. So I subtract 3x on both sides of the wall, and then I simplify. 5x minus 3x gives me 2x. I brought down the equal sign. 3x minus 3x became 0, so they disappear, and I bring down the 8. So 2x equals 8. I circled the variable, brought down the wall. I divided both sides by 2, so I found that x equals 4. Now I'm not finished, so I didn't box it. They want the perimeter. So now I just substituted a 4 in for x, and so I found the base was 5 times 4, which is 20, and the height was 3 times 4 plus 8, which is also 20. So the perimeter would just be 20 times 4, because there's 4 sides, and so it would be 80 units. And you're finished.